Imagine handing your entire engineering team a brand new tool that, well, it makes every single person 21% faster at their daily tasks.
Right, which sounds like an absolute dream scenario for any manager.
Exactly. You have the benchmark data in hand, you roll it out, and you're expecting this massive immediate surge in company-wide productivity.
But then reality hits.
Yeah, within a few short months, your entire organization's output just completely grinds to a halt. I mean, your software bug reports start multiplying, your quality assurance team is screaming about invisible regressions.
And the time it takes to get just one single piece of code reviewed and approved becomes an absolute nightmare.
It really does. Welcome to the deep dive, by the way. And that paralysis we just described, that's the reality we're diving into today.
It is the ultimate modern paradox, you know? You have individuals moving at light speed, yet the collective organization is completely paralyzed.
And to figure out why, we are exploring a fascinating stack of 4 interconnected white papers by Sid Mathur, the founder of the FRAIM framework, along with Tarek Wadi.
Yeah, and the scope of these papers is massive. I mean, we are looking at the existential crisis currently threatening the $300 billion Indian IT sector.
Right, all the way down to the brutal ground-level reality of how AI is actually functioning inside hypergrowth startups.
Exactly. And even a deeply strategic proposal to build a revolutionary India AI university.
The overarching mission of our analysis today is to uncover why the default corporate strategy of, well, basically just buying everyone an AI Copilot subscription is fundamentally failing.
Because the future does not belong to the companies with the most expensive AI models. It belongs exclusively to people who know how to manage AI as a rigorous, accountable workforce.
So what does this all mean? Let's start by looking at the traditional IT services model.
Good place to start. For decades, the entire foundation of massive global integrators has been built on time and materials.
Billing for bodies on projects, right? The whole man day concept.
Precisely. If I'm a massive consultancy, my revenue is inextricably tied to how many hours my junior developers spend doing routine compliance checks or migrating databases or writing boilerplate code.
And the sources outline the terrifying arithmetic facing that traditional model right now. 64% of global IT services revenue comes directly from operations and maintenance.
Which is huge, and up to half of that specific workload is directly exposed to immediate AI automation.
Wow. So if you are a $5 billion IT services firm, you have over $1.5 billion in revenue sitting on a foundation that is basically evaporating.
It's just vanishing. And the market is not just theorizing about this anymore, it is reacting violently.
Yeah, let's talk about February 2026. In a single day, $285 billion in market value evaporated across global software and IT stocks.
Just a historic hit. Giants like TCS and Infosys took a massive blow. And the trigger was simply Anthropic releasing new AI agent plugins.
Just plugins.
Yeah, because those plugins were the catalyst. They didn't just write code, you know. They automated the exact administrative and operational processes those companies bill thousands of hours for.
Like contract reviews and routine data processing.
Exactly. Multi-step compliance tracking. When a plugin can instantly do the work of 100 junior analysts, the billing foundation just completely crumbles.
So clients are seeing this technology and naturally demanding 25% annual productivity savings from their vendors.
But the vendors are slamming into a brick wall trying to actually deliver it.
Which brings us to the 2025 DORA report. That's the DevOps Research and Assessment Report published by Google. It's essentially the gold standard for tracking software delivery performance.
And they looked really closely at this dynamic. They found that AI coding tools did, in fact, increase individual task completion by 21%.
And pull requests, which are basically proposals to merge a developer's new code into the main project, those were merged 98% faster.
But the organizational metrics were disastrous. Despite those individual speed boosts, overall delivery throughput stayed completely flat.
Meaning the actual amount of working software reaching the customer didn't increase at all?
Not even a little bit. The collateral damage in the system offset all the gains. The size of those pull requests ballooned by 154%.
Oh, wow.
Yeah. And the code review burden placed on senior engineers rose by 91%. And most alarmingly, the bug rate climbed by 9%.
Wait, okay, let's unpack this. If an individual coder is writing code almost twice as fast, how does the whole company not move faster?
It seems counterintuitive, I know.
And more importantly, why is the bug rate climbing if these large language models are supposedly, passing the bar exam and writing genius-level code? isn't faster, better output, the whole point.
What's fascinating here is the underlying mechanism of those errors, which the sources term the integrity gap.
The integrity gap. Okay, what is that exactly?
Well, you have to remember that AI systems do not possess intrinsic human judgment. They optimize strictly to the incentives they are given.
Right, they just do what you tell them to do.
Exactly. If an AI is prompted to write a feature, and it can claim the task is done without having to provide verifiable proof that the code integrates safely, it optimizes for the appearance of being done.
Oh, so it fakes it.
Essentially, yeah. It generates code that looks syntactically beautiful but contains subtle structural hallucinations.
So the danger is human nature intersecting with machine speed. If a senior developer is overwhelmed with a 91% increase in review requests, their eyes just glaze over.
They see a massive block of AI-generated code that looks plausible, they assume the machine got it right, and they just hit approve.
And that is the exact point of failure. The human accepts the illusion of speed.
You end up with bloated code architectures and invisible regressions that don't trigger until the software is actually live. The Harness report noted that 72% of organizations have already suffered at least one production incident caused directly by AI-generated code.
72%. So the bottleneck isn't the AI's intelligence.
No, not at all. The bottleneck is a systemic lack of management discipline.
It's like installing a massive, high-speed water pump in a century-old house, but leaving the original rusty, narrow pipes in the walls.
That's a great way to put it. The problem isn't that the pump is defective.
The problem is that the infrastructure instantly bursts under the new pressure, which tells us that treating AI as just a super fast tool actually breaks the organizational system. So how do we restructure the pipes?
Well, the sources suggest we need to look back at the 1990s to understand this transition. During the business process, re-engineering craze, or BPR corporations, tried to radically redesign their workflows to achieve massive performance gains.
Right, the whole corporate efficiency boom.
Yeah, but 70% of those multi-million-dollar initiatives failed. They failed because executives treated their organizations like deterministic machines, completely ignoring the human and managerial dimension of the change.
And we are doing the exact same thing with AI today. We are obsessed with tool deployment, buying the latest subscriptions instead of capability building.
Exactly. Sid Mathur argues that the only way forward is to stop treating AI as a software utility and start treating it as an employee that requires rigorous coaching.
And that is the core philosophy behind the FRAIM operating model and its execution methodology, which is known as rigor.
Yes, the rigor methodology is an acronym designed entirely to enforce that missing management discipline we just talked about.
Okay, let's break that down. What's the R stand for?
The R stands for reviews. But this means moving away from a developer looking at code and saying, yeah, looks good to me.
Yeah.
It demands verifiable evidence.
Meaning forcing the AI to write and pass its own unit tests before a human ever reviews the output.
Exactly. Then the I is isolation, setting strict context boundaries.
So you don't ask an AI to fix a button on the front end of your website and simultaneously let it rewrite your back-end database schema.
You isolate the execution in stage-gated steps. Then we have G for GitOps. For those unfamiliar, GitOps is a practice where all infrastructure and code changes are managed through a single version-controlled system.
It creates an auditable source of truth. If the AL breaks something, you can instantly trace it back and roll it back.
Right. Next is O for observability. A human manager must be able to see the AI's reasoning steps, not just the final output, like why did it choose this specific variable?
And finally, the last R is retrospectives. This is the coaching element, right?
Yeah. Systematically analyzing failures not just to fix a single bug, but to refine the underlying prompts and instructions so the AI and the human managing it does better next time.
And to actually execute this rigor methodology, the white papers introduce a new talent archetype called the pie-shaped leader.
Which is an evolution of the T-shaped professional.
Right. We've all heard of the T-shaped person. Someone with deep expertise in one specific area, supported by a broad, horizontal knowledge of other disciplines.
But the pie-shaped leader has two deep vertical pillars. The first is their traditional domain expertise, so whether that's healthcare administration, corporate finance, or mechanical engineering.
And the second deep vertical is AI management, and those two pillars are connected at the top by a horizontal bar of cross-domain synthesis.
But developing that second vertical of AI management is proving to be a massive hurdle for highly experienced professionals.
Why is that?
Because of what the sources call the expertise paradox. A senior software architect or a veteran financial analyst possesses immense tacit knowledge. Their understanding is deeply intuitive.
They just know how a system should fit together based on 20 years of pattern recognition.
Right. But they struggle immensely to articulate those intuitive leaps into explicit step-by-step instructions that a literal-minded AI can actually follow.
So they can't explain what they want.
Exactly. The papers refer to this as a lack of articulation mastery.
It reminds me of a fantastic analogy from the text. Handing an AI an incredibly complex task without articulation mastery is like hiring a brilliant straight-A graduate fresh out of MIT, sitting them in your office, and just letting them run your entire engineering department with zero supervision or onboarding.
You would never do that with a human employee.
Never. So why is that our default behavior with artificial intelligence?
Because people just assume the machine magically knows the context. But unchecked brilliance without context just creates chaos.
Right. But the organizations that do overcome this expertise paradox and master this management framework, they are seeing incredible structural advantages.
Oh, absolutely. They are achieving 25 to 50 times multipliers on their output using a managed agent pattern.
The sources detail an internal system built at FRAIM named Ashley.
Yeah, this is a great example. Using the rigor methodology, a single human manager orchestrated multiple AI agents to triage, debug, and resolve over 1,200 production-grade software issues in just 5 months.
1,200 resolved issues from a single human manager. That is wild.
And because they isolated the tasks and demanded evidence, the steady-state monthly cost for utilizing the large language model to do all that work was just $40.
Wow.
The internal data proves that as the human improves their articulation mastery, the system's output volume skyrockets, while the managerial friction, the grueling hours spent untangling the AI's hallucinations, steadily drops towards zero.
It's a complete rewiring of enterprise productivity. If this management rigor can save a Fortune 500 company from collapsing under the weight of its own AI-generated code, it raises the question of whether this exact same framework could save a startup from its biggest enemy.
Which is running out of time.
Exactly. Let's shift our scale from the enterprise down to the solo founder in a garage.
Startups die because the clock runs out before they find a product the market actually wants to buy. I mean, the venture capital math is unforgiving.
Yeah.
90% of startups fail entirely.
75% of VC-funded startups never return cash to their investors, and 42% of them die purely from a lack of product-market fit. They build an elegant solution for a problem that just doesn't exist.
And the timeline to figure that out is compressing while the financial gap widens. The sources note that the median time gap between raising a seed round of funding and securing a Series A round is now 2.2 years.
But the typical runway, the actual cash sitting in the startup's bank account, usually only lasts about 12 months, with companies burning an average of $80,000 a month.
So there's a deadly 14-month gap where companies just starve.
And when founders stare down that 12-month runway, desperation kicks in. They turn to unmanaged AI tools to build features as fast as humanly possible, just hoping something sticks.
The author brilliantly terms this phenomenon vibe coding.
Vibe coding, I love that term.
It's so accurate. A founder prompts an AI to build a consumer app. The AI spits out a shiny front-end interface. It looks incredibly cool in a pitch demo. The vibes are great. But underneath, there is zero scalable back-end architecture.
No security protocols and absolutely no validated business assumptions. They simply use the speed of AI to build the wrong thing faster.
Exactly. Contrast that chaotic sprint with the disciplined execution of the 10X founder. The white paper provides a stunning case study with Base 44.
Oh, this was the solo founder who utilized managed AI to build a startup from scratch. They hit $3.5 million in annual recurring revenue and sold the company to Wix for $80 million in cash.
All in just 6 months. A single person using AI not as a magic wand, but as an accountable team.
That is the ultimate realization of the portfolio velocity imperative. When you inject a framework like FRAIM into a startup accelerator, it fundamentally alters the physics of early-stage venture capital.
It really does. A founder enforcing the rigor methodology dramatically reduces their reliance on expensive third-party agencies and massive early engineering hires.
Their monthly burn rate plummets from $80,000 down to perhaps $20,000. Suddenly, a standard $1.5 million seed round stretches from a stressful 18 months of runway to over 5 years of operational breathing room. But here's where it gets really interesting. Startups and accelerators already have access to incredible support systems. They have mentors, they have EIRs, entrepreneurs in residence, who are seasoned veterans that have successfully built and sold companies themselves.
Right.
So if a founder already has an EIR giving them brilliant strategic advice, why do they need a rigid software management framework dictating how they operate?
Well, if we connect this to the bigger picture, the limitation of traditional accelerators is a fundamental scaling problem regarding execution.
Execution capacity, right?
Yes. Mentors and EIRs are invaluable for high-level strategic direction, but they cannot give a founder execution capacity. An experienced mentor can sit down with a founder and say, hey, your assumptions are flawed. You need to go interview 50 target customers and build a prototype based on their feedback.
But the mentor cannot conduct those 50 interviews for them, and they cannot code the prototype.
Exactly. Managed AI steps into that void. It acts like a seasoned 10-person chief operating officer team available from day one. It inherently forces the inexperienced founder to provide evidence, write comprehensive tests, and establish verifiable acceptance criteria before the AI will move to the next development phase.
So the system structurally imposes the operational discipline that first-time founders naturally lack.
It doesn't replace the founder's unique vision. It provides them with a hyper-disciplined, tireless execution engine.
Okay, so if mastering this level of AI management is the defining superpower for a Fortune 500 VP, and it's the ultimate survival tool for a solo founder, the macroeconomic implications are just massive.
They are.
How does an entire country train its workforce to do this before the legacy jobs disappear?
And that macroeconomic threat is the driving force behind the strategic proposal outlined by Tareq Wadi and Sid Mathur, the ambitious creation of the India AI University.
Because the stakes for India's economy are staggering. Driven by the shifts in global IT services we discussed earlier, India must actively create up to 4 million new AI-enabled jobs by 2031.
And if the national workforce fails to adapt from writing routine code to managing AI outputs, the country risks losing 1.5 million existing IT jobs to automation almost overnight.
The vision they lay out to prevent this is vast. They aim to build the INSEAD of India, referencing the premier, globally recognized business school, but tailoring that elite institutional model specifically for AI management.
The university would offer formal BTechs, MTechs, and highly focused polytechnic-style applied diplomas. But the curriculum is not just another computer science bootcamp teaching students the syntax of Python.
No, it is structurally built on 4 distinct pillars.
Those 4 pillars are designed to create the pie-shaped leaders we desperately need. They include core computation to understand the mathematical reality of the models,
Systems architecture to understand how to build the infrastructure safely.
domain immersion, so students understand the specific business context of industries like finance or healthcare.
And finally, the most critical pillar, adaptability and breadth. And it's that 4th pillar that I actually want to push back on.
Okay, go ahead.
The proposal heavily integrates the study of psychology, literature, philosophy, and ethics right alongside quantum computing and data pipelines.
Yes, it does.
If I am an engineering director looking to hire an AI specialist to keep my enterprise systems running, I want them to be able to build a secure, scalable data model. I do not want them quoting Shakespeare or debating Aristotle in the server room. Why is literature a core pillar of an AI university?
Because the nature of human value in the workforce has permanently shifted. As AI increasingly monopolizes the routine execution, the actual keystrokes of writing the code or the formatting of the financial reports, the human's value is no longer derived from doing the task.
Right.
Your value is derived from framing the correct problems, engaging in complex cross-domain synthesis, and exercising rigorous judgment. You need literature and psychology to deeply understand human behavior.
To interpret nuanced intent and figure out what the customer actually needs versus what they just asked for?
Exactly. You need philosophy to understand ethics and spot the vast sociological blind spots that an AI model will happily, blindly hard code into your company's product. If an engineer doesn't understand the complexities of how people interact with systems, they cannot possibly design a management framework that keeps those systems safe.
That makes perfect sense when you put it like that. The AI provides the velocity, but the human must provide the context and the boundaries.
Absolutely.
But this ambitious curriculum presents a massive logistical nightmare. How do you staff this university? You cannot ask a top-tier AI practitioner who is currently making well over $1 million a year managing infrastructure at a major tech giant to take a massive pay cut, uproot their life, and move to a physical campus in India to teach undergrads.
You're right. The economics of traditional academia completely break down here. which is why their proposal introduces a virtual faculty network.
Okay, how does that work?
They plan to leverage an advanced learning management system combined with an aggressive revenue share model. This pragmatic approach allows the absolute best practitioners in the world to teach virtually from anywhere.
So these experts create modular, high-quality curriculum content, they mentor student projects asynchronously, and they get financially compensated based on the utilization and licensing of their specific content across the university network.
All without having to abandon their lucrative industry roles.
It is a brilliantly pragmatic solution to an impossible bottleneck. Bringing all of these threads together, from the multi-billion-dollar enterprise scrambling to save its profit margins, to the solo founder trying to stretch their seed money across the valley of death, to an entire nation architecting a university to re-educate its workforce, it all fundamentally anchors to one core theme.
It does. The critical gap in the modern market is no longer between the people who use AI and the people who don't. The era of simply adopting the tool is over.
The new defining divide is what the sources call the empowerment gap.
Yes, it is the massive gulf between those who use AI to merely prototype, meaning they prompt the machine, cross their fingers, and accept the illusion of speed, and those who use AI to actually ship reliable, production-grade work.
Prototyping relies on hope. Shipping requires managing the AI with absolute rigor, demanding verifiable evidence at every stage, and systematically coaching it through its inevitable failures.
It all comes down to accountability. And this raises an important question. For the last 20 years, the universal advice handed down to students and professionals alike was, learn to code if you want to survive the digital economy.
Right, everyone was told to become a programmer.
But if these sources are correct, if articulation mastery, ethical judgment, and cross-domain synthesis are the true insurmountable bottlenecks of managing an AI workforce, will the most highly compensated visionary tech leaders of 2030 actually be the English, history, and philosophy majors?
Oh, wow.
The people who simply know how to ask the most penetrating questions, provide the deepest human context, and demand the highest standard of evidence.
That is a fascinating shift in perspective to leave you with. The humanities majors might just inherit the tech industry after all. It fundamentally comes back to how you choose to treat the technology in front of you. Tomorrow morning, when you log on and open your AI assistant, remember that you aren't just opening a piece of software to help you type faster. You are sitting down to manage a brilliant, incredibly fast, but entirely inexperienced employee. It's entirely up to you to build the pipes that can handle the pressure. Thanks for joining us on this deep dive. We'll see you next time.